number. I was just looking at the signs.
One is lack of empathy, and the other one is lack of understanding of consequences.
Right. I think that was it. But like somebody was saying that it wasn't really lack of empathy; it was lack of sympathy.
Yeah, but we all have to go through that phase, as teenagers, right?
Yeah.
All right. Well, let's go ahead and get started. This is our last lecture of this entire semester. So I will start with a chart that I just made a few minutes ago. This is a spreadsheet. It gives you an idea of the distribution of scores at this point, including everything that I have graded. Sub 1 and Sub 2 have not been graded, but it's not included in this chart either. So we'll take a look at this chart. It's not going to take long. You already know your positioning in class because I think I turned on that aspect of
in the grades.
Huh? In the grades, yeah. So in this case, let's see. Let me zoom out. Nope, that's the wrong one. Okay, so this is the chart, representing. Let me get rid of all of the other ones. Why is that chart standing on its own? There we go. Now we have only one left. And it's just a chart. Let me see if I can zoom out. Yep, there we go. That's not how I want it to open. Okay, let's do it one more time. Oh, okay, I know what happened. I just exported the chart itself. So let's. Oh, that's not good. Okay, I need to zoom out first too, so it's easy to view the whole thing. There we go. Okay. So this is a chart that I made, just a few minutes ago, and you can see that, okay, 100%, from this minor mark here all the way out here, those are basically all A's. So starting from this bar here all the way to this bar, we have a whole bunch of, I would say about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So about 14 A's at this point. Not counting the final exam or Sub 1 and Sub 2. So you're only using everything that I have graded at this point. These 14 people are getting an A out of this class. But there's no guarantee because, if someone, currently has an A but bombs the entire, final exam, they can bump that person down to a B or possibly a C, okay? But those people cannot fail this class anymore at this point. Yep, go ahead.
Sub 2, what is the impact of that?
Sub 2, I think, has 20 points, I think. Yeah, so it's weighted based on the number of points for the homework assignment. And then the next bunch of people, starting at about this point here, all the way down to here, which is the range of B's. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, about 16 people getting B's out of this class at this point, okay, using only things that I have graded. Which is also kind of interesting too, because you can see this little bump here from the B range to the A range, and also there's also another bump here from the C range into the B range, and that's not my doing. I didn't do a single thing. This is just exactly how the grades are distributed. Okay, so centering around 50%, which is starting from about here, I would say about here or so. Those are all C's. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are about 10 C's at this point. And then below this point, would be D's. So 1, 2, about 3 D's at this point. So that's how the overall grade of this class is currently distributed. Are there any questions about how the grade is distributed at this point? So I think overall speaking, as a class, I don't think we are doing too bad. Okay. So the final exam is about the same kind of question, about the same type of I'm looking for the same kind of thing. Can you solve problems basically in the final exam? So I don't think that the shape will change too much. I think it would be about the same, after the final exam. Okay. All right. So now that we have this, I can keep this one up, just in case somebody wants to refer to it later on today. So once we have taken a look at this one, we'll go back and look at topic 9, where I have opened up a few documents. And these are basically practice exams for your final exam. The one that I want you guys to kind of focus on would be Spring 2013 final exam, because that one also does not have any mentioning of records. In other words, I got to about the same place as this class last semester, which is kind of good because it's consistent. It's a single zip file, and within the zip file there are multiple files inside, and you can do this on your own when you're home too. Just open up the zip file, and let's see, where is my, okay, I might need to do it by hand. Okay, so it opened up a final exam folder. Okay, so I can just go back to my file.
It shows the questions individually.
Sorry? Okay. So in this case, I unzip the whole thing into my temp folder. And these are the files that you should see. We have the questions. There are 6 questions total. And I don't know what happened to the question number 6, because these are the answers. I think I might have merged the question with the answer itself, and that's why we see all these. So we'll go ahead and take a look at these questions one by one today, and see if you guys have any questions. I think I might have promised either this class or the other one, I cannot remember which one, but I did say something about let's focus on the pre and post condition one first. So let's go ahead and do it that way, because the mechanical ones are not, they're just mechanical, you just have to trace it. But this one, is not as mechanical as the other one, so we'll deal with this one first. Okay, so once again, we have a pre and post condition thing using a conditional statement. And in this case, we know ahead of time that x has a value of -8 and y has a value of 5, and we want to figure out what is pre-1, according to this code. So that's the question. Okay, it's kind of the same kind of question that you got in exam number 2. Okay, except this one has different type of assignment statements on lines 2 and 4, but if you look at the condition itself, it's very similar, if not identical, to the one that you have in exam 2. But the way you treat it is really kind of the same thing. Okay, it's the same way to approach this one as the one in exam 2. So we'll go ahead and take a look at this one and find out, how can we get back into pre-1 and go forward again. Okay. If you read the question, it's basically the same thing. This one only requires the backward derivation, but in our current class, I also need you to go forward again. So going backward is kind of optional, showing the steps, but going forward is not optional. So in this case, I'll just go ahead and do it in both ways, in both directions. All right. So the post condition is given to you, right here. I'm just going to make a copy of that. Post 5 is x equals -8 and y equals 5. In other words, I can basically say that I use a debugger, and I stop after line 5, and then I print out the values of x and y, and this is what I'm observing. I'm observing that x has a value of -8 and y has a value of 5. So the question is it possible for me to reverse the steps and basically say on line 1, this condition has to be true? Okay, that's what we are doing, which is the same thing that we were doing in exam 2, except this one is a little bit different. Okay, so what we can now say is, well, if that is the condition at post 5, It might come from post 4, it might come from post 2. So we'll try to follow each path up and see which one makes sense, okay? They can both make sense, by the way. So we can say, let's say post 4 is the same thing, x is -8 and y is 5, okay? In that case, if this is the post condition of line 4, is there a way to reverse what we know about post 4 and get back to pre-4, okay? Now, if you look at what line 4 is doing to y, it is just adding 1 to y. So if I know that after adding 1 to y, it ended up with a value of 5, can we reverse that operation and say, oh, y must have this value before? Okay, so what should it be? 4? Okay, exactly. Okay, so we'll say, well, it doesn't touch x, so x should still have a value of -8. Y should have a value of 4, and on top of everything else, because it is in the else case, so that means the condition of x is greater than y has to be false. So I will just say that it's not the case that x is greater than y. And then in the next line, I'm going to do some simplification here. Okay, it is not the case that x is greater than y means x is less than or equal to y. And is there any conflict here? Is any condition, any component of the conjunction conflicting with the rest? Nope. Okay, x is -8. -8 is less than or equal to y. So that means x is less than or equal to y is not really adding any additional information. We can just say that, well, since it's not giving me anything extra, I can simplify it. Okay, but this simplification is not required. If you don't want to deal with the simplification, hey, you know what? You don't have to do it. Okay, so either ending with this line here is fine with me, but if you want to take it one more step, you can also do the simplification here. Okay, now that line 4 is done, let's take a look at post 2. Now, since post 2 also leads directly to post 5, when we reverse the steps, we can also say that, well, if this is post 5, this can be post 2 as well, because I could have come from line 2 to get to the end of the conditional statement. So now we can say post 2 is also 8, x is -8, and y is 5. Okay, because that's one alternative to get to the end of the conditional statement. Now, if we look at line 2 is changing the sign of x. In other words, if x is +10, it becomes -10. If x was 0, it remains as 0 because the negation of 0 is itself. Okay, so after the negation, we have a value of -8. So what would be the value of x before the negation? 8. Just 8 itself. Okay, so x equals to 8, y equals 5. And in this case, because line 2 is the first line of the then branch, so that means the condition of the conditional statement also has to be true. So this is my, this is my pre-2. Okay, I forgot to write that down. Okay, so now we look at this entire conjunction here, and then we ask the question, is there anything conflicting here? Because if there's anything conflicting, like, two things cannot be true at the same time and it's in a conjunction, then the entire conjunction is false, which means we could not have come from this branch. Is there anything here conflicting? No. X is 8, y is 5, 8 is greater than 5 is okay. I mean, it doesn't cause any problem. But at the same time, x is greater than y doesn't add any new information either. So I can just simplify this whole thing to just, x is 8 and y is 5. All right. So at this point, I have pre-4 and pre-2 done, okay, because each of the branch I have taken care of that already. So now I can just combine those two to pre-1. The precondition of line 1, can be, if I trace my ways backwards, it could have come from line 2 or line 4. So at this point, I can say pre-1 is pre-2 or pre-4. Oops. And this is where it is kind of important to use parentheses, because just like in arithmetics, you perform the multiplication first and then the addition if there are no parentheses. In logical expressions, we also do the conjunction first and then the disjunction if there are no extra pair of parentheses. So that's why in this case it is important to add the extra parentheses. So we'll go with pre-2 first. This is our pre-2. And this is our pre-4. That's it. There's no way to simplify this. Okay, this is really just the answer. Okay. So are there any questions about this particular question up to this point? Okay, just getting back all the way to pre-1, given what we have as post 5. No questions? Okay. So the next thing we want to do is to double check, right? I mean, well, we can go back, but this means that if we start with pre-1 being this, we should be able to get to post 5 and end up with the same post 5 that was given to us in the question. Okay, so now we reverse the whole thing and then we go forward again. And by the way, in exam 2, quite a few people forgot to go forward from pre-1. So depending on whether those people show steps and also show the reasoning going backwards, I sometimes give partial credit, so that because I can see the reasoning, I can see some people even using substitution and all the other reasoning to go backwards. So I give those people some partial credit, not full credit, but partial credit for showing all those steps. Okay. So in this case, I'm going to go forward again, and to go forward again, I will say, okay, let's take a look at pre-2. Okay, so let me just make a little separation here. Okay, go forward from pre-1 to double check the answer. Okay. Okay, now because of the structure of the conditional statement, pre-2 is pre-1 and the condition of the conditional statement, because otherwise we would not be about to execute the first line in the then branch. So knowing that, we'll just go ahead and expand what is pre-1. Pre-1 is this entire disjunction here, and then we have a conjunction outside of the disjunction. When you see something like this, you can use the distributive rule of Boolean algebra. It's just like the distributive property of multiplication and addition in arithmetic. Okay, if you see a plus b and then the whole thing times c, okay, this is just ac plus bc. It's the same thing here, except you substitute the plus with a disjunction, and you substitute the multiplication with a conjunction. But it works the same way. All right, so knowing that, we can now just kind of make this expression a little bit longer by combining those two. So we'll end up with, well, I'm just going to copy and paste this portion here. And then for each conjunction in the inside, I just add the component that is introduced because of x is greater than y. Like so. Okay, so now we have, again, we have two big conjunctions, and they are joined by a disjunction. So I'm going to look at each conjunction individually and say, well, is there a way to simplify this? In this case, with the highlighted portion, 8 is greater than 5 does not conflict with x is greater than y. In fact, it contains more information than just x is greater than y. So as a result, we're going to say, well, x is greater than y is not getting me anything extra. So I could have just stayed with the original form, which is x is 8 and y is 5. And I'll just keep that portion here. Okay, that's how I simplify the first one. Okay, let's take a look at the second one. The second one looks like this. Okay, it tells me that x is exactly negative 8. It tells me that y is exactly 4, but it's also telling me that x is greater than y. It cannot be, right? That's impossible. So if it is impossible, that means the expression is false. Okay? Regardless of the values of x and y, this expression has to be false. Well, actually, I shouldn't say that, because we know exactly that x is negative 8 and y is exactly 4. So x is greater than y cannot be true at the same time. But if it cannot be true at the same time, that means this component is false, which means true and false, hey, that has to be false. Okay? Anything or false is just anything, because it's just like anything times 0. Okay? If you have y times 0, that is just 0. Okay, so if you substitute the multiplication once again with conjunction, and you substitute the 0 with false, then this rule of identity holds as well. Okay, it's kind of interesting how many concepts that we understand and have used for years in arithmetics also kind of apply to Boolean algebra, because algebra is algebra. Okay, there's a broad class of systems in mathematics that have similar properties. So in this case, we can do some of the simplifications, and then we can go to pre-4 is pretty much the same thing. Pre-1 and x is, well, we can do the post first. It doesn't matter. I usually go with pre-2 and then pre-4 and then do with the post of both of those. But you can choose to do it the other way too. We can do it the other way. Okay, if we want to derive post 2, then we have to think about, okay, what exactly is line 2? Well, line 2 is an assignment statement. If you start with an assignment statement, there are only 2 ways to get to the post condition. Okay, you either apply the forget operation when the right-hand side is not reversible, or you use the substitution operation when the right-hand side is reversible. Okay, and I think it's a good time to pass the exam back to you guys, although it might cause some distraction because it's a big pile. Those people in the back are actually luckier because by the time it gets to you, the pile is smaller. Then you don't have to go through as much stuff. All right, I'll start this first portion here, and eventually you guys will have the cross path. And the good thing is we have a row of people sitting all the way to the back of the classroom, so they can just pass it back, to the other side. And since I know several people, I'm going to pass these to you guys first. It's not marked, so there's no marking on it. That's why we can pass it around to the class. Just don't flip into the exam of some other people and say, well, let me see how that person answered this particular question. Okay. So post 2 is based on either the substitution operation or the forget operation. We use the substitution operation when the right-hand side is reversible. So when you look at this, go ahead. Yours is not in there.
Might be in the app.
Oh.
Yeah, exactly.
I'd rather was another half. This bag is really small for this entire class.
Yeah, it's okay. If you don't get it in the other half, then we have a problem.
Yeah, yours should be the last one. Yeah, last one.
Yeah.
Which is nice because that means you don't have to sort through the whole thing.
That's true.
Yeah. Well, you still technically have to search, but your array size is 1, so you only need one comparison to confirm that that item is the item that you're looking for. So, well, it is an algorithm class, right? So. Okay, so in this case, we need to look at the right-hand side. So we say the right-hand side of line 2 is f of x is the negation of x. Okay. So the question now is does this function have an inverse? Okay, is there a way to reverse the effect of negating a value?
Yes.
Well, the answer is yes. Okay, the inverse function is itself. Okay, it's another negation. Is the inverse function. So as a result, we use the substitution operation. And to use the substitution operation, we basically say the post condition of line 2 is the result of using the substitution operation on the precondition of line 2. We locate all the occurrences of x and replace every single one with the inverse function of f applied to x. Okay. All right. So this is the template. Okay. Some people did not write down the template, which I think is going to be helpful. So this is the template. We copy and paste the precondition of line 2 itself. Oops. Yep, that's right. Okay, and then f of x itself is just the negation of x. So that means we look at the original thing, and every time we see x, we replace it with negation of x, like so. If you just leave it like this, it's okay. Okay, I'm not gonna take any points off. If you just leave it like this and you consistently use it throughout the entire derivation, it's going to be okay. And that's one thing that I observed too in exam too, is sometimes there are inconsistencies. Okay, so somebody would say the precondition of line 2 is like this, or the post condition of line 2 is like this, and then when it comes to post 5, it's something else. It just magically got changed to something else. So that is not a good thing. Okay, that's not a good thing. It has to be consistent. Self-consistency is good. Okay, but since I understand the negation, and it's conventional for me at least to try to make the variable side just as simple as possible and move all the operations to the constant side. So I personally like to do it like this, but you don't have to, because it really means exactly the same thing. So now we move on to the precondition of line 4, and the way we work this out is about the same as the precondition of line 2. So pre4 is pre1 and the negation of the condition of the conditional statement. And then we just do pretty much the same thing here, except we have a negation on top of everything. Well, on top of x is greater than y, and then we apply the rest just the same. Okay, except we have a negation here. All right. Okay, now the simplification is a little bit different because, because this time the first conjunction says x is 8, y is 5, and it is not the case that x is greater than y. Well, obviously the third condition, not x is greater than y, conflicts with the first two. So that means the first two are true, and then the third one has to be false, which means the entire conjunction is false. Okay. But the second condition is okay. The second conjunction is okay because we have x is -8 and y is 4, and x is less than or equal to y basically. And that's okay. It's just that this particular condition doesn't add anything new to it, so we don't. Yep, go ahead.
Is it supposed to be false and or false or?
Oh, it's a or. That's right. How did they get an and? Okay, it is or, so that means the previous one may be wrong too. No, the previous one is okay.
Some people
Okay, so are we doing okay so far with the distribution of the exam? I thought about passing it to each person individually to make it more personal, but that's going to take up a lot of time, and I don't have time today. This is our last lecture, so I want to kind of do this part instead. Okay, so now we have false or something, and that means we just have the other side, like so. And I'm simplifying the whole thing too. I get rid of x is less than or equal to y. So it's an extra one.
There's a couple of them.
Oh, okay. People who are not currently here, I guess. That's one good way to take a row.
Yes.
Wow, there's a big pile. Oh, okay. Go. All right. So that's pre-4, okay? So now that we have pre-4, we have to, okay, now that we have pre-4, we can try to derive post-4, and it's basically the same thing, except in this case it's actually easier because if you look at line 4, it's just, x gets x plus 1, and we already know the inverse is just y minus 1, which is, y gets y plus 1, so the inverse is y minus 1. So now we can say the right-hand side of line 4 is f of y is y plus 1. The inverse function is y minus 1. Use the substitution operation. And so we just apply the substitution operation on the post condition of line 4 is the result of applying the substitution operation on the precondition of the same line. We change all the occurrences of y with y minus 1, and the rest is pretty mechanical. So we just take what is pre-4, which is this expression here, and then we change it to the only one we have to change is the second one. So we have y minus 1 equals 4. And of course, if you want to do the simplification, which is, optional, y gets 5. Y is 5, excuse me. Y is 5. Okay. Are there any questions at this point? We have post 2, we got post 4, and because of the structure of a conditional statement, post 5 is a disjunction of post 2 and also post 4. So now we just say, okay, let's do some copying and pasting here. We got post 2 up here. We got post 4 down here. Wow, magically they are exactly the same thing. So if you want to go through the simplification, you can just do the simplification. But if you don't know that you can simplify it because the two sides of a disjunction is identical, you can just leave it the way it is. I mean, just leave it as, x is negative 8 and y is 5, or x is negative 8 and y is 5. That doesn't bother me. But the last step is kind of nice because it is clean. It gets back to the precondition of line 5 that I gave you in the question. So
Wait, is it an and in the middle or?
it is a or. I keep typing the wrong thing.
I thought it was an or, but then the other
No,
one.
it's an and. This one is an and. Okay, good one. Good try. No, this one is an and because the two sides of the disjunction are identical, so I just picked
Right.
one. Yep.
I thought maybe she meant like the top line of post 5 where it says post 2
And
post
yeah,
4.
like that, yeah.
Oh, that one is wrong. Yeah.
Yeah. 'Cause I was
There,
here.
there we go. Good job.
I got that though.
Okay. So is that okay so far? Yep.
So I'm a little bit confused about how you're simplifying out, like pre-4, for example, the
Okay.
where it gives x is less than or equal to y, and also the false there. I'm a little
Okay.
bit lost on that.
Okay, so let's go from one line to the next, okay? From here to here, it is just an expansion of pre-1.
Right.
Is that okay? And then from here to the next line is the use of the distributive property of disjunction and conjunction. Hmm?
What do you mean by that?
Distributive property means, A and B, the whole thing, or C, is the same thing as A and C. Whoops. Let's see, this is A and C. No, the other way around. The and is on the outside. The other way around works too, but in this case, the or is in the in. No, the or is on the outside. The and is on the outside. See, the and is on the outside, the or is in the inside, so this is the way it is. Okay, so A and C, or B and C. That's the distributive property. It's the same thing as, A plus B times C is AC plus BC, so it's basically the same thing, except it's, applied to Boolean algebra instead. Okay, but how do you prove something like this? I mean, it's nice to have it, but is it actually true? I mean, is it actually true that for any Boolean values, independent Boolean variables A, B, and C, that the left-hand side, A or B, the whole thing, and C is the same thing as A and C, the whole thing, or B and C as a whole thing?
Yes,
Well, how do we prove it?
with a proof.
With a proof, the proof is going to be a table, right? The truth table. So you enumerate all possible values of all combinations of values between A, B, and C. Well, that's not possible when you're dealing with integers because there's an infinite number of integers. But when we are dealing with Boolean values, it's okay because A can either be true or false, B can only be true or false, C can only be true or false. So that means as a total, you only get 8 possible combinations. If for all 8 possible combinations of values of A, B, and C, that these two expressions have exactly the same result, then you can say one is truly equivalent to the other one, because you have just proven that for all possible cases, they are identical. So that's why in Boolean algebra, proving an axiom is actually easy. Whereas in arithmetics, an axiom is an axiom. You just have to say, okay, that's an axiom, and we don't question that. But in Boolean algebra, we can actually question it and say, okay, is that really true? Well, by the definition of the operators, that has to be true. So that's how we went from this to this. Okay. So the way we did that is this is basically our A. This is basically our B, and that is basically our C. So that's how we can kind of merge A and C together to become this portion, and then we have B and C together to become this portion. Okay. Now what if you don't know anything about Boolean algebra and you cannot do any of this derivation? Well, there were a few people who did not do derivations like what I do here. Well, in that case, if you just kind of stop here and say, that is my pre-for, and consistently use this pre-for in the derivation of your post-for, I will give you full credit. And that's what I did with exam number 2. In exam number 2, a few people did not want to risk the derivation just in case, oh, what if I do something wrong, then I'll get points deducted. So a few people just kind of left the expression kind of complicated and not simplified, kind of like this. But you know what? As long as your post-for is derived using exactly that, and your mechanical part of doing this is correct, I will give you full credit. This is not a Boolean algebra class. As important as it is in programming, this is not a Boolean algebra class. Yep.
So when you were going backwards to derive pre-1 from your post-5,
Yep.
you didn't do any sub-operations or anything like that. Do we not have to do that when we're going backwards?
In exam number 2, I did not even ask for steps for going backwards. So a few people did it anyway. They'll show all the steps, which is good because some people did all the steps going backwards and then do all the steps going forward. So those people got 100%, assuming those steps are all correct. Some people only do the steps going backwards and then forget to do it forward again. So some of those people get partial credit because they show the steps, and I say, well, if you can reason out this much and show me the steps, that clearly shows that these people also understand how everything are kind of linked up. So I give partial credit for those people.
So on the final, when we get to a pre-post, we don't have to show all our steps to derive to pre-1. We just have to do it when we go forward.
Correct. Unless I ask specifically, show steps going backwards too. Yep. All right. So any questions about this particular one? So there are many directions you can go with this, and there are multiple answers that I can consider completely correct. But I just go for the full board here, do all the simplifications, apply everything that I know about Boolean algebra, so that we end up with a nice and concise conclusion. Are there any questions? Yep.
Just like on the test, I only got 25% on my pre-post area because I did the whole forward and I didn't understand how to go. So is it when you're going down, you just use the sub and the forget? Like that's like the part that I was forgetting.
The part I just forgetting.
It's the sub and the forget.
Yeah. You have to reason out why you are using one or the other, and then it has to be applied correctly as well in order to get full credit for post
I
to
followed
a
it
post
like
for.
you would if you were tracing. Like I was just like, well, you'd add 3 and then you.
It's
do this,
not.
and then-
That's why it's not tracing. Pre and post conditions is a little bit different from tracing. Yep.
Finals, same thing. Open book, open notes.
Open book, open notes. No electronic devices.
Sure.
Unless you want a simple calculator, I can go to the dollar store, the Dollar Tree, and get a whole stack of simple calculators for anyone who wants to say, I need a calculator to do mod, right?
But anything we have on. Anything we can put on paper.
Yeah. Anything you put on paper, books that you can, that you find useful, it's okay. And for anyone who's religious, who decides, I need to read a religious, book to calm myself, that's okay with me too. Not a problem. I mean, some people may find it pacifying, help to focus. That's okay.
So they're Hail Marys or whatever.
Yeah. No alcoholic stuff again. That's it. Bloody Mary, no Bloody Mary.
No.
Yeah, no burning of incense either. Okay, that's it. Anything that doesn't disturb the person next to you in the rest of the class. Well, paper was once made from hemp,
Yeah.
right? Yeah. So that can have side effects. All right, so that's the first question. We'll move on to the second question now. Yeah, side effect is the understatement. Okay, so here's question number 1. So question number 1 is, just use the following table to look up your test case, based on your student ID, the least significant digit. So I just have a whole bunch of random numbers here, and you have to apply all that stuff. So I'm not going to focus too much on that part. I'll just do the trace here, okay? Because I think that's really just the important part.
So is that like if we have a 0 in our ID number, it's 0?
If you have an ID number of 0 in this case, then your K1 would be 3 and K2 would be 9 to start with, and you plug in those on lines 13 and 14 to initialize A and B.
Gotcha.
So that means,
I'm just confused because it says, I know it's semantics, but it says the least significant rightmost digit. So
Yeah.
is that just the last digit
it's,
in your ID number?
well, but when you say last, it can be on either side. So this is the rightmost, which is the least significant digit of a number.
Okay.
Yep.
I just want to make sure the finals Tuesday or Thursday?
Thursday.
It's on
Friday.
Thursday.
What
It's
time?
Friday. Come on Friday.
Yeah.
What time?
10:15.
It's it's on Moodle too.
Yeah.
So
10:30. 10:15.
let's see here. Where is it?
10:15.
News, events. There we go.
It's my birthday.
The final exam is on the 19th, and it goes from 10:15 a.m. to 12:15 a.m.
It's a birthday. Picking it on Monday.
All right. So getting back to the first question, right there. Okay, so I'm just going to trace the entire algorithm. I'm not going to just give you the answer to that one. Yep.
I do have a quick question about the final. How much is it worth of our total grade?
40%. It's in the syllabus. Yep.
So we're about halfway done with this semester.
However, we only need 37.5% to get a C out of this class so we can get into cisp 360. So if you ace the final exam, then, it's all good.
Does this class transfer?
This class usually is not transferable because this is a pre-C++ class, basically. And then almost all 4-year universities start with a C++ class. So that's why this class by itself may not be transferable. You might want to check because it might transfer as a GE class. Okay, so somebody checked already?
Math classes, certain math, like you require to only take this one, and other ones you require to put 60 to C+. So it depends on, for math majors, it depends on what school you're going to.
Okay.
Like if you're going to Humboldt, they only want you to take this class. But if you're going to Chico with math, they want you to take up to CISP 400. So
400. That's object-oriented programming. That's one class after 360.
yeah, so one class after 360. So it depends on where you're going.
Okay. Well, not that it's not a good class, but it's
useful,
not
but,
as applicable, right? Okay. So we have this code here, and we're gonna go, figure out what it's gonna do. Okay. And let's see here. Line 15 is kind of problematic because it's kind of long, and I cannot show the trace as well. So what I'm gonna do is I will shrink this one here, and then make this cell wrap around using is under alignment, and we say wrap text automatically. There we go. So this way we can show more of the trace at the same time. All right, so there we go. We need one column for comments because I do have print statements here, and I need somewhere to indicate what I'm printing. And then we have our usual line number. Okay, so with the precondition here, the first thing we want to know is, do we have global variables?
No.
Okay, no, we don't. Okay. And that's because when you look at all the names that are referred to in the algorithm, x and y in Q1, x is a by reference parameter, y is a by value parameter, so that all the names are accounted for. In subroutine main, we have a and b, and they are both local variables. So now we have all the names accounted for, and that's why we don't need, we don't have any global variables. So the precondition is easy to state when there are no global variables. We start on line 17. Now, just because most of the programs that I write do not have global variables, doesn't mean that in the final exam you will not encounter global variables. So always double check first. Okay, always double check. The return line number is post, and then we have two local variables a and b, and because they are local variables, they always start with unknown values, which is they're starting with a question mark.
What is the part that says integer mean?
That's actually part of the discussion where we start to talk about types. Up to this point here, when we say, oh, there's a local variable, we just say, hey, it's a variable, but we don't know what kind of value it can store. With some programming languages like PHP, Perl, and most scripting languages, a variable can store different things at different times during the execution of a program. So at one instant of time, maybe it stores an integer. At another instant of time, maybe it stores a name. And at the third instant of time, you can store a Boolean value, true and false. But in a compiled language like C++ and Java, it's called strongly typed, which means you are going to restrict what kind of value a particular variable can store. And that's just me using that convention here to basically say A can only store integers and B can only store integers. That's a good question. We have not talked about that in this class because that's actually kind of a pre-topic to records. But it's not interfering with what we do in this class either. It's just some additional stuff that we have never seen before. All right. So now that we have set up all the columns, we continue execution on line 13. Line 13 is pretty easy. Okay, A gets the value of K1, and I'm going to refer to the question itself to find out which K1. I'm going to assume that we are using the digit of 0 here. So K1 is 3, K2 is 9. So let's switch back to my spreadsheet here. Okay. So K1 is 9, and then the other one is 13, I think. Okay, so on line 14, we put 13 into B. Is that right?
It was 3.
It was 3? Okay, gotta get rid of 1.
3.
Okay, 3 and 9, that's right. Okay, thank you. 3 and 9. And then on line 15, we have to deal with the print statement. But printing is really the last thing that we have to do. We got 3 things we have to do before the printing. We have one invocation on the left-hand side of the addition. We have one invocation on the right-hand side of the invocation. So those 2 invocations both have to be resolved before I can even perform the addition. After the addition, then I can do the printing. So that means, well, we have to deal with the invocation first in this case. You can deal with the left one or the right one first, because in addition, the C++ programming language does not specify the order. Okay. In other words, sometimes the compiler can decide, hey, I want to evaluate the right-hand side first. Okay, and other times it can evaluate the left-hand side first. So in this case, we don't have a strict requirement to go from left to right. But since we read from left to right, that's the convention that I'm going to follow here. Since we are invoking a subroutine that returns a value, we have to use return info. And when we are done, we are going to come back to line 15 because line 15 has got something else to do. I'm going to use the order of left to right, so I'm resolving the left invocation first. So that means the right invocation is not being dealt with at this point, and I'm just going to write it exactly the way it is in the original program because, hey, I'm not even doing it now. I'm not dealing with it now. So that's why when we come back onto line 15, maybe we'll deal with it at that point. And then we have to set up the parameters. There are two parameters to Q1. We have X and Y as parameters. And according to line 15, we are using A to specify parameter X. Local variable A is in column D, so X is going to be an alias of column D. Y, on the other hand, is passed by value, and I specified the value of B, the local variable B, to specify parameter Y, which is passed by value. B has a value of 9 at this point, so the expression B also has a value of 9, and that's why Y as a passed by value parameter has a value of 9. Are there any questions about how these three columns are set up? Okay, no questions? Okay. I'm going to keep the return info kind of, truncated at this point because it's not important at this point. So I'll just kind of leave it, truncated. And then we move on into the subroutine that we are invoking, which is Q1. Q1 starts execution on line 5. Line 5 doesn't do anything too complicated. We are just saying, okay, look at the value of Y and print it out. Y has a value of 9 at this point, so I'm just going to print a value of 9 on line 5. We move on to line 6. Line 6 wants to compute the product of X and Y. Y has a value of 9. X is an alias of column D. Column D currently has a value of 3. 3 times 9 is 27, and we store it back into X. But X is only an alias, so we don't store that in column G. We store it in the column that column G is referring to, which is column D. So column D is the one that gets a new value of 27. Are there any questions at this point?
So you're simply referencing column D in that by reference.
Right. You do not change the column of a passed by reference parameter, because you look up what it's referring to and then you change the column that it is referring to. So moving on from line 6 to line 7. Line 7 is printing the value of X. X is also known as column D. We look up column D, and you have to be really careful because we have to look up the most up-to-date value on the column before you print it. So you say, okay, it has a value of 27 at this point, and then we move on to line 8. Line 8 is a return statement. It simply changes the question mark of a return info cell to the value that we are returning. Okay, it's returning X here. Okay, X is also known as column D. Column D has a value of 27 at this point. So to return X is to basically say returns 27. So we'll just copy and paste the entire return info cell, change the question mark to the value that we're returning, which is 27, and we're done with the return statement. And then we move on to line 9. We have two things to do. Yep, go ahead.
Well, see, sometimes you'll, whenever you have a return like that, you'll put it under that return info line, but sometimes you'll put it right under the value. Oh, wait,
Right
no.
under the value.
Like, you would put it under the sum in the last trace we did.
Under the...
Sorry, I'm just...
We always change the return info cell. When we execute a return statement, we only change the question mark in the return info cell from the question mark to a new value.
Oh,
Yep.
I know what he's talking about. He's talking about because we were doing, it was like you were doing return sum, and
Plus
then you were doing
something.
sum goes to sum plus question mark. So
Right.
then that sum was going into that question mark because it was returning to that. And then it was after that, the line after that, the sum was changing to basically the sum plus.
After we return from the subroutine to the line that contains, sum plus something. Sum gets sum plus something. Yep. That's a statement. Sum gets sum plus something. But the sums are not exactly the same sum. Okay, so we are now on line 9. We are executing line 9. Line 9 is the end of a subroutine, has got two things to do. Look up the rightmost return info cell, copy and paste it to the line number. And then the second thing we do is to deallocate the columns that we allocated earlier for this invocation. And we go to font effects, cross it out. And now we continue execution on line 15. Okay. On line 15, right now it is print 27 plus invoke blah blah blah. So I'm not quite ready to do the addition yet because I need to know what is the right hand side of the addition. So we have to perform a second invocation of Q1 at this point. Okay. So that means when we execute line 15, we are now doing pretty much the same thing as last time. We have to allocate return info. Return info. We have to allocate a column for parameter x, another column for parameter y. Okay, let's deal with the easy one first. Y is getting its value as a parameter, is getting its value from the expression a here. A is referring to my local variable a in main. I'm still in main, by the way, which currently has a value of 27. So that's why we put a 27 here in column H. Parameter x, on the other hand, is getting its is a reference to local variable b. Local variable b in main is column E, so that's why parameter x is also known as column E in this case. Are we doing okay so far?
Do that one more time, please. Do that one more time, please.
One more time?
Yeah, just cut the sequential.
X or Y?
Let's start with Y and see where.
Okay. Okay, we're dealing with the right-hand side of the addition. So we use A as an expression to specify the start value of passed by value parameter Y. This A refers to local variable A of main because we're still executing in main. Main has, local variable A in main is column D. Column D has a value of 27. So we use the value of 27 to specify the start value of parameter Y. And that's why parameter y starts with a value of 27. Is that okay? Then we move on to x. X is passed by reference. So that means whatever is to the left-hand side of the double-sided arrow has to be something that has storage. This is local variable b. Local variable b is using column E, and that's why parameter x becomes an alias of column E because it's an alias of local variable b in main. Is that okay? Yeah. All right. So now we get to the return info here. We still have to go back to line 15 because after this invocation, okay, this one is already resolved to 27, but the second one is the one that we are resolving at this point. So that's why we're still returning to line 15 because we still have the addition and the printing to do when we get back onto line 15. And once we set up everything, we continue execution in Q1 starting on line 5. Line 5 is printing y. Y has a value of 27. So we'll just say print a value of 27. Then we move on to line 6. Line 6 is trying to compute the product of x and y. X is also known as column E. Column E currently has a value of 9. So we have 9 here. And then y has a value of 27. So we have 9 times 27. 9 times 27 is, well, I'm cheating here. That's the nice thing of using a spreadsheet. 243. And it is stored, if you look at line 6, it's stored into X. X is also known as column E, and that's why I'm updating column E to a value of 243. Then we move on to line 7. Line 7 is printing X. At that time, X, which is an alias of column E is already updated to a value of 243, and that's why on line 7, we are printing a value of 243. Are there any questions about this part? No questions? Okay. Then we move on to line 8. Line 8 is returning the value of X. So once again, we look up X. X is an alias of column E, Then we look up column E. It currently has a value of 243. So 243 is the value that we are returning using the return statement. So we copy and paste the return info cell, change the question mark to 243 because that's the value that we are returning. But we don't combine 27 and 243 to what, 270, because this is not the right time to do the addition. Even though it is staring us in the face and saying, hey, we can do the addition now, don't do it now because it is not the right time. We are not on line 15. Yep.
Is that because that line right there on row 19 of the spreadsheet is the return statement?
Yeah, exactly.
Okay.
The job of a return statement is really just to erase the question mark and then replace it with an actual value. But we don't do a single thing about what that piece of paper is saying. We're just changing the question mark to something. We are just replacing the placeholder with an actual value. We are not on line 15 at this point. Okay. So now we are done with line 8. We move on to line 9. Line 9 is the usual thing. It's the end of a subroutine. Look up the rightmost return info cell, which is this one here. Copy and paste it to the line number column. Remember, in the final exam, you can just say line 15 if you want to, but you have to mentally track what is line 15 at this point. Okay, what is left to do on line 15. So if you only write down line 15, then you have to mentally track that. Okay, so we are going back to line 15, but we are executing line 9 at this point, which also means we have to remember to deallocate all the columns to be allocated for this invocation, and then we are finally back onto line 15. So this time, when we are getting back to line 15, we say, hey, we have 27 here, we have 243, we can certainly do the addition at this point, which is 270, and we will go ahead and do the printing to finish up here line 15. After line 15, we move on to line 16. Line 16 is the end of a subroutine. We look up the rightmost active return line number. In this case, it tells me to continue execution at post. And then we have no use of these 3 columns anymore because this invocation is coming to an end. So whatever we allocated for this invocation has to be deallocated also. And then we continue execution at post, which means we are now done. We are at the finish line. Okay. Are there any questions about this one? Now, the form of question that I'm asking in the exam is just to tell me what values is printing, which is basically saying, okay, print 9, 27, 27, 260, 243, and then 270. Which is good in a way because if you can mentally track the execution of the algorithm without a trace, you don't have to spend all the time to write down everything, right? But it's bad in a way because for whatever reason, if your calculation is off or you miss a step or something, then your answer is wrong. I have no excuses to give you partial credit. So it's good and bad at the same time. Yep.
Are we going to have like a blank table to like at least draw the trace if we want to, or are we just going to have to?
I'm going to change the form of the questions to be more like our exam 2, where I will. It's still important to know how to trace it. Okay, so I will ask you to trace a part of it. So instead of tracing something that's really long and complicated from start to finish, I will do part of the trace. Okay, I will say, okay, this is, I work it up to this point here, and then just take it for the next, 5 or 6 steps, just to see, so I can see whether you can finish, just 5 or 6 steps and not to run into completion. Okay. So are there any questions about this one? This is Q1. No questions. We'll move on to Q2. Let's see, back to my... Okay, so we talked about question 4, which does not have an included answer, which is good, okay? All of the other one have an answer. So that means, if I don't have time to go over everything, you can actually at least, look at the question and then look at the model answer to those questions. Let's take a look at question number 6, because question number 6 doesn't have a question sheet, and it just has the answer. So this is the one, and it doesn't have a question. Oh, this will be a good one. But only has sheet 1, so I wonder where the question is. because I can't find the question. Well, but this would make a very interesting question, is to give you the trace, and then you guys will give me the pseudocode.
Extra credit.
Yeah.
Extra credit.
Okay, let's take a look and see whether that is even possible, shall we? Okay? I think it's
Well, it looks
good.
like the question is how many columns are in the.
Well, that's a
arrays,
part of the
because
question.
That's part of the
Yeah.
answer.
A part of the question is how many columns would be in use. That's one part of the question.
Right.
The other question, if you look at the highlighting, is the print one, which is asking, okay, what is this algorithm printing? So those are the 4 lines. It will print 1, 1, 1, and 1. But let's take a look at the trace here and see if we can reverse this back to the algorithm. Okay. Now, it is not always possible because there's always ambiguity. In other words, if the test case only executes a part of the original pseudocode, then there would be a part of the pseudocode that we can never reverse engineer because we never step into that portion. But let's take a look and see if we can apply some reasoning and problem-solving skills and reverse the whole operation. In other words, start with a trace and then get back into the pseudocode. Do you think that would be a useful skill set?
Absolutely.
Why so? Who would hire you if you can just look at the trace of something and be able to reverse the code?
Yeah, or malware, or a security specialist.
Security specialists look at the forensics, right? Look at the traces left behind, from an attack. You can try to trace your steps backwards and figure out what happened. Okay, company that wants to reverse engineer products from other people. Okay, same thing. And I highly recommend the movie Paycheck if you're
That's
interested in
amazing
that sort of
movie.
thing. Yeah, it's totally underrated, right? Most people look at Paycheck, it's like. And I was just, absorbed in that movie. It's like, cool.
I was talking about that yesterday, because I was saying they should do that for pregnancy. Like, as soon as you start labor, they should just stick a chip in your head, and that way you don't remember all the pains. They just like, wipe your brain. No.
And
Bunch of men in the classroom
then 30 years later, there'll be a 30-year-old and say, "Mom, do you remember me?"
Well, I was thinking like as soon as like the first labor pain comes, you stick the chip in, and then like as soon as the baby's out, you wipe back. So like you have one labor pain, and then you see the baby. You're just like, yeah, that's an awesome memory of birth.
As soon as the baby starts crying, put the
Yeah.
chip back in.
Yeah.
I want the first 2 years of the life. Just not,
It's like these problems do grow up.
no late nights.
All right, so we're going to reverse this program as much as we can here. Okay, I think this is a good exercise. Okay.
It's not going to be on the test, is it?
It's not going to be on the
Okay,
test.
thank goodness.
However, well, not something this complicated. I might give you something simple because we, okay, here are like 5 traces of the same algorithm, but with different start cases or test cases. So go ahead and tell me what the program looks like originally.
Please
This
don't.
devious laugh you've come up with over the last couple of days.
That's like free post,
Ever since
except
the
on
advent of
crack.
substitution.
On crack.
Not okay.
Okay.
I really, really don't want you to do that.
Extra credit.
Extra credit. You can see how I can use opportunities like this and go like, where's the question itself? Oh, I can ask questions like that. Okay, so on line 32, I know it's an invoke statement because it allocated a bunch of columns. Okay, actually, I don't want to talk about this one because this one has records in it. I can tell already, because local variable v has 2 fields. One is field A and one is field B. The first field has 2 more fields on its own, and it's a local variable. So I can tell right away it's out of the scope of this class. Okay, so it's okay not to talk about it. I'm so bummed.
It's records.
I'm so bummed here.
Index arrays.
Okay, this is question number 2. Okay, so question number 2 has no, we just got through that. Okay, so let's look at question number 3. Okay, here's question number 3. I think this will make a good one because it has only concept that we have talked about in this class. And let's just take a quick look and see what it does. Okay, here we go. All right, this is question number 3, and that's why the subroutine is Q3, question number 3. So once again, I'm going to ask, in the question itself, it will ask, how many columns are will be used up in the maximum, and also, tell me what it is printing, right? So in this case, what do you think? Let's take a look at the question, the subroutine itself first. It has 2 parameters. One is parameter A. It is passed by reference. It is an array of integers. Okay, so right away we know it is a reference to a bunch of columns and not a single one. I is passed by value. Okay, it's just a single value. Print I doesn't look very difficult at all. Okay, now we have a conditional statement. The conditional statement is saying, okay, as long as I is less than bar A bar, go ahead and do the following. The first step involves a recursion. It is calling Q3 again. The first parameter is not really exciting because I'm just passing my own parameter passed by reference to me, A, along to the next invocation. Not very exciting. The second one is using I plus 1 to pass to I. Now this one is telling you, combining this portion of the recursive call and also line 5, you know that eventually it has to stop. Okay, because if I start I with 0, okay, then each time I go through line 6, the value of parameter I will increment by 1. Okay, so if I start with 0, it becomes 1, 2, 3, 4. So eventually I will be the same as bar A bar, which means the conditional statement will have nothing to do because there are no else's in the outer conditional statement, and then we'll just start to unwind the columns and go back. Okay. Let's take a look at if A bracket I is less than 5, then we do the following. It prints the value of A bracket I. Okay, we're just dereferencing an array in this case. And the else part is, maybe this is the part that can be a little bit challenging. The only part of the program that is a little bit challenging is really this part here. What am I doing with this line?
It's the absolute value.
It's not, no, we don't, the bar A bar is not used, it's not absolute value. It's the number of elements in array A, okay, minus 1 minus I. Now the most important part is you have to evaluate whatever is in the square bracket first, so it becomes a single integer, and then use that one single integer to indicate which element you want to access in the array. That really is the most, I think, the trickiest part of this entire algorithm, is this part here, okay? Evaluate everything, the whole expression inside the square bracket, and then use that value to tell you which element you want to access in the array. So don't do just A bracket I and then say, oh, I want to do a subtract 1 or something else. You need to evaluate this entire expression first. Okay, that's about it. I mean, it doesn't do anything. It doesn't change the content of the array. So if you look at the question itself, we run the following algorithm on line 16, initialize all elements in array B. So the B bracket 0 is the leftmost digit of your student ID, and so on. So in other words, the array is going to be initialized to the 7 digits of your student ID, and so the behavior of this algorithm depends on your student ID. Different students will have different output from the same algorithm, which is what I really like about questions like this. Yep.
Since you're asking for what's printed and you want the line number, you're going to give us enough time to actually run the algorithm, right?
Yep. Well, you kind of, okay, you have 2 choices. You can either trace the entire thing through and figure out what it's going to do, or you can analyze the algorithm, because once you analyze the algorithm, you have a pretty good, if you can understand it and be able to mentally keep track of things, then you can also run it that way too. It's just run it in your mind, and it's only asking you for what it is printing.
And if we can, we're going to have enough time.
Then you do the full trace, right? Now the full trace is actually demonstrated in, this is Q3, right? Yeah, I have the answer here too. So if you look at Q3 answer, this is the answer. Okay, this is the actual answer based on the assumption that the student ID is 1347254. So it's printing 4, 5, 6, 7, 4, 3, 2, and it uses up up to 20 columns in this case. And well, it does get a little bit over here. Okay. Now, what about in your case? I mean, if you want to really test this program and test, whether you can get it to run and work the way that it's supposed to, you probably want to plug in your own student ID instead of the one that is kind of fake here. So you can just plug in your own student ID here. I hope this does not actually match a student ID because I'm just making it up. Sometimes I punch in numbers like that and it turns out to be a prime number. When we talk about factoring, what are the likelihood that I can find a prime number like that? Obviously not this one. And just watch, observe now. See, the algorithm just changed. I mean, the trace just changed. So if I changed it, a little bit here, change that to a 5, to a 6 here, you can see the output, also changes because the printing part is actually based on, the program executes differently, depending on the conditions.
So what's can I see your cells for like D6, E6? What's the, okay.
So I made use of an Excel, not Excel, but a spreadsheet function to do it. And then the funkiest part would be the conditional statements. Because sometimes the conditional statement is true and other times it's false. So I have to kind of do it like this, which also means the next line that it executes is also going to change too. Well, this one doesn't change, but the other one does. When we're on our way back for this comparison, this next line here depends on whether the condition is true or false. So it does something differently depending on the condition. So this spreadsheet, kind of takes care of that.
What's this typewriting?
Yep. Punch it in. Look at the trace. Look at the print. The numbers printed. See, the point is to make it easy for me to grade. So this is fairly easy. I just punch in the number, but I do have to spend time to work out the spreadsheet itself. I can assure you this is not from a textbook or anything. Okay, and we'll just quickly take a look at the other ones. Well, now that we talked about this one, you can just go ahead and try it out and do it on your own. Let's finish up the other ones. So that's question number 4. We talked about question 4 already, so we only have one question left, which is question number 5. Once again, I will use another spreadsheet to take a look at this. All right, so this is the algorithm, and this one, once again, only make use of concepts that we have talked about in this class. Arrays, passing by reference, passing by value, returning something. It does kind of combine things in in an interesting way. So once again, we have. Okay, this is bad because I used, it should be a left close square bracket and not a close parenthesis. So that's a typo. So when you do this, there's a typo here. So once again, you have to kind of pay attention to the square bracket. You have to evaluate the expression inside the square bracket to find out which element you want to access first. So that's, any questions about this? And by the way, this one is not a typo. It really is I plus I, which is 2 times I. Okay. In other words, this one only goes through, quote unquote, 1/2 of the array. But that's because when you get to line 5 is doing something that's kind of funny because it's comparing one element with another element in the array. But those 2 elements are kind of related. If you go through that expression, I versus bar A bar minus 1 minus I, you will find out, the pattern, what it is comparing to. It's not the next one, okay, but it's somewhere else in the array, but it is related. You will find a pattern of, of accessing it. So for question number 5, if you go through the folder, it also has as an answer. So this one gets a little bit more complicated. So that's why I have a special column just to show what kind of value is returning. Okay, so you can go through this and good luck with your final exam. And bring extra sheets of paper just in case you need some extra sheets. Okay, so that's always a good idea. Yep.
Google evil kid meme.
Evil what?
Kid meme. Evil kid meme.
Evil kid
Meme.
M-E-M-E.
M-E-M-E. Mimi.
Meme.
It's not bad. This is exactly what you might now.
Yeah.
I should just send you an email about my grade.